group will present on the topic of the application of thin layer chromatography or TLC. So without further ado, let's get started. So what is chromatography? Well, chromatography is a separation technique used to separate compounds of the mixture based on the different rates at which they move through the stationary phase and the mobile phase. In thin layer chromatography or TLC, there is a thin layer of silica gel or alumina that is coated on a glass, plastic or an aluminum plate. The mobile phase is a suitable solvent that moves up the plate through the capillary action. So, TLC is widely used because it is simple, fast, low cost, and requires only a small amount of samples. It is used in pharmaceutical analysis, food testing, and forensic science. It is used for preliminary screening before more advanced techniques such as HPLC. It also helps chemists to quickly determine whether a mixture contains one or more compounds. Not only that, it is also widely used in teaching laboratories as an experimental technique. So, the theory of TLC is that it is given by the formula Rf, which equals to the distance traveled by the compound divided by the distance traveled by the solvent from. The core principle of TLC is that compounds with stronger interactions with the stationary phase will take longer time to move, and compounds with weaker interactions will move further and therefore faster. So, the solvent is used to determine the separation of the compound. So, selecting the correct solvent is important to achieve a good separation. So the movement of each compound is represented by the Rf or retention factor. It ranges from 0 to 1, and that also means that some compounds may have similar Rf values, so comparison with standards are actually necessary.
Next part is methodology, step-by-step practical process. First, dry a pre-coated TLC plate to remove moisture. This helps the compound stick to it better. The secondly is use a tiny tube to put a small, concentrated dose of your mixture near this bottom of the plate. So moreover, place the plate upright in a covered chamber filled with a small amount of liquid solvent. Make sure liquid level is below your sample dot so it doesn't wash away. Furthermore, the liquid will clean up the plate naturally. As it dries, it carries the mixture with it and separating it into different spots. So, last but not least, take the plate out and immediately mark how high the liquid clean. So, if the spots are invisible, look at them under UV light or spray them with specific chemical to make them show up. Lastly, make sure the distance the solvent travel and the distance each spot travel. Divide the spot distance by the solvent distance to get the Rf value, which help identify the compound. As you can see here, so this is example of the result where TLC analysis is the separation of plant pigments, distance traveled by solvent 8.9. Where pigment A travels 6.4, we put our data into the formula. Rf 6.4 over 8.9 equal to 0.8. For pigment B, travel 4.6 cms. Rf 4.3 over 8.9 equal to 0.5. So comparison of this Rf value with the reference value helps in the identification of the compounds. However, it is important to note that Rf values alone are not always sufficient for identification, so as they might change depending on experimental conditions such as solvent type, temperature, and plate material.
Moving on to application of thin layer chromatography, which is TLC. So TLC, or stand for thin layer chromatography, is a simple, fast, and low cost method used to separate, identify, and monitor different substances in mixture. One of its most important uses is in food analysis. TLC helps detect food additive, preservative, coloring, and contaminants to make sure food is safe to eat. It also used to analyze food components such as vitamin, sugar, and fat. Because of this, TLC is widely used in food quality control. The researcher wanted us to understand that food contain mixture of compounds. Chromatography can separate this compound. Chemical has practical application in everyday life. We divide our material into 4 groups. The first one is beverage leaf and fruit vegetable and citrus peel. Most of the material is extracted using ethanol. Tomatoes and carrots were extracted using ethyl acetate because they contain non-polar compounds that do not dissolve well in ethanol. Now let's look at our first result. Different food produce different TLC pattern. This is because each food has different chemical composition. So on the left is group 2, which includes spinach, tree leaves, and blueberries. Spinach and tree leaves produce many colorful spots on the TLC plate. This shows that contains several different pigment and chemical compounds. On the right is group 3, which include carrot and tomatoes. This sample produces a bright orange spot near the solvent front. This indicates the presence of non-polar pigment called carotenoids such as beta-carotene and lycopene. So overall, this result shows that a TLC can separate and identify different plant pigments based on their chemical properties.
Next is result 2, which is blue spot after CMM staining. After treatment with CMM stain, compound appear as blue spot. Different food samples show different numbers and positions of spot. This confirms that each food extract contain a different mixtures of chemical. As you can see, the A1 we have beverage, we use coffee and green tea, and the B1 which is the leaf and fruit, we use spinach, leaf, blueberries, and the C1 we have vegetable, we use red cabbage, tomato, and carrots, and the D1 we use citrus peels, we have lemon peels, lime peels, and also orange peels. Next is result 3, which is mix and match experiment. Extract from different group and analyze them together. Sample that we use is orange peels, spinach, carrots, and also coffee. The co-spot lens show all spots from the individual sample, confirming that TLC successfully separated compounds from multiple food sources. Why do different food produce different spots? It is because it contains different chemical compounds. For example, tea is contain polyphenols and caffeine, spinach contain chlorophyll, tomato contains lycopene, carrots contain B-carotene, citrus peels contain essential oil, and so it become like different polarities. They travel different distance of the TLC plates, producing the separate spot. Why were tomato and carrot spot near the solvent front? It is because the solvent system contain a relative non-polar component, contain non-polar carotenoid pigment, dissolve well in the mobile paste and travel further up the plate. This is why an orange spot appear near the solvent front.
Our TLC analysis was successful. By separating the compound in food extracts, each sample shows its own unique pattern. We used a steric ammonium molybdate chem stain to make the invisible compound appear as blue spot on the TLC plate. The co-spot experiment also shown that TLC can separate compound from different samples on the same plate. Overall, this proved that the TLC is a simple, fast, and effective method for separating and identifying compounds. In conclusion, thin layer chromatography (TLC) is a simple, fast, and useful method for separating and identifying compounds. It works by using the different interaction of substance with the stationary and mobile phases. From the food extract case study, we saw how different pigments were separated and identified. Overall, TLC is an important technique that is widely used in food analysis, quality control, and many other laboratory applications. So that's all from our group. Thank you.